Right. So today we are going to do the 2020 past paper. Okay, maths paper. Okay, right. Right. So the question one. So this is not a difficult paper. Okay, you can easily pass this paper. Actually, this paper is easier than the semester one maths paper. Okay, because it's all about logic. Right. Question one. Which of the following is equal to? This is integers question. X to the power 2, then the cubic root. So cubic root means 1/3. So therefore answer is very straightforward. X to the power 2 to the power 1/3. So that is x to the power, when a to b is ab, 2 divided by 3. So this is an answer. Sorry, not this. This is not the answer. Multiple answers are possible. So this is an answer. This is also the same, right? 2 to the power 1/3 or 1/3 to the power 2 is the same. No, right? No. Yes. 2 divided by 3. Yes. So this is an answer. Because 2 to the power 1/3 or 1/3 to the power 2 is the same. So this is half to the power. No, this is not the answer. This is 1/6. This is not the answer. So the answer is B and C. B and C. Second one. So these are very simple questions. Okay, you don't get this kind of question even for O-level. X to the power -1 means 1 over x. Y to the power -1 means 1 over y. Z to the power 2. That is what kind of a question is that? This is a grade 5 question. Right. So the answer is either you can write this also as Z to the power -2, 1 over x, y, Z -2. So therefore this is an answer. This is not an answer. You have to simplify this and see. X squared, x cube means 1 over x. Y and y squared means 1 over y. Z cube and Z means Z to the power 2. So therefore this is also answer. Right? Because that is Z to the power 2. So this is Z to the power 2 divided by xy. This is an answer. So this is -1. That means 1 over. That is x, y, Z -2. So this is 1 over x to the power -1, but what we need is 1 over x. So therefore this is not answer. Okay. So remember, x to the power -1 means 1 over x. Right? If we have x to the power a to the power -1, that is 1 over x to the power a. So therefore this is 1 over x to the power -1. What we need is 1 over x. So therefore answer is ACD. ACD. Second one, ACD. Yeah, third one. Log 927 is equal to which? And log 927 means what? Now look at the answers. Log 3 answers are there. Log 3 answers are there. And these are just normal answers. Okay. Right. So when you say 9 to the power 27, first of all, you have to see whether can I write this as 9 to the power? No. Because 9 to the power 1 is 9. 9 to the power 2 is 81. Okay. So therefore, you can't write it as 9 to the power. Okay, let's see. So therefore, you can't straight away write. But you can write it as, you know the change of base formula. Log AB can be written as log CB divided by log CA. So therefore, shall we write it in log 3? So that then it will be log 327 divided by 3 or 5 or any number, log 3, 9. 27, I can write it as a power of 3. 3 to the power 2 is 9. 9 to the power 3 is, so 3 to the power 3 is 3 into 3 into 3, 3 into 3, 9, 9 into 3 is 27. So this answer is there. Log 327 divided by log 39. So this is an answer. Okay, log 39 I can write. Log 39 is 9 is 3 to the power 2. So therefore this is 2. So therefore another answer is log 327 divided by 2. Sorry. 27 is 3 to the power 3, right? Yes. Yeah, yes. Sorry. So anyway, this is answer. So log 327 is 3 because 27 is 3 to the power 3. And log 3 9 is 3 to the power 2. So therefore 2. So therefore 3 divided by 2 is also answer. Right? Sorry, 27 is 3 to the power 3. So when 3 divided by 2 is answer, 2 divided by 3 cannot be answer. Okay. So this is not answer, definitely. What about this? Can we write division as a subtraction? No, there's no such thing. If you have something like log x divided by y, yes, you can write log x minus log y. But this is not log x divided by y. This is log something divided by another log something. So there you can't write it as subtraction. Okay. So therefore answer is B and D. Right? Third one answer is B and D. B and D. Now you must have all the indices rules in single page, right? All the log rules, right? Indices rules, log rules, all the Boolean algebraic rules, all the rules related to probability. Okay, all the rules related to probability. All those must be there. Right. Right. Formulas මතක නැතුව exam යනවා කියන්නේ නිකන් අර හරි ආයුධ නැතුව කඩු මේ සටනට ගියා වගේ ඊට වැඩි ගොංකමක් තවත් නැහැ නේද අනිත් උදේ ආයුධ ටික අරන් ගියාට වැඩක් නැහැ ඔළුව නැත්තම් logical thinking නැත්තම් හරි logical thinking දිනුට වැඩක් නැහැ සමීකරණ ටික මතක නැත්තම් හරි ආයුධ ටික අරන් යන්න ඕන ආයුධ වලින් සටන් කරන විදිය දැනගෙන ඉන්න ඕන පුහුණු වෙලා යන්න ඕන හරි ඒකට ගණන් papers 5ක් 6ක් කරන්න කියන්නේ maths වල right so question 4. Which of the following is are correct? I think this question is there almost every year or almost every other year. Okay. Right. So log a uv can be written as log a u plus log a v. Right. Log a uv can't be written as log a u minus log a v. Therefore, this is wrong. What about log a 1? Is it log a 1 0? So log a 1 means log a. Can I write a to the power 0 is 1? Then log a to the power 0 is 0. So therefore 1 is a to the power 0. So therefore yes, log a 1 is 0. Right? Log a 1 is 1. No. What about this? Log a uv, can we write it as log a u into log a v? No, there's no such rule. Multiplication become additions. Okay. Right. So what and here remember these bases must be natural numbers, right? Yeah, a uv must be natural numbers. Yes, they are natural numbers, so therefore we'll take that. Okay. So the answer is A and. If you have any doubts, just let me know. Okay, A and C. Any other answer? You gave me another answer, right? A. Maybe this is for the previous one. Okay, right. So the answer must be A and D. Sorry, A and C. Right, A and C. 5. So that is very easy question. So my question then දැකලා පුරුද්ද තියෙන්න ඕන. Right? Fast progress කරලා තියෙන අවුරුදු 5ක් විතර. So this is the solution for this one, x, and this is y is the solution for this one. Right? So what we need is x intersection y. You don't have to worry whether this is x or y. Those are ultimately what we need is numbers. So therefore, don't get fooled, think that this is x, this is y. Ultimately, what you need is numbers. Okay. So therefore, what they ask is which solution is common to both this one and this one. Okay. So this is the easier one. Y squared minus 1 means y difference of squares, right? Y plus 1. Y minus 1 is 0. So that means y plus 1 is 0 or y minus 1 is 0. That is y equal minus 1 or y equal plus 1. So there are two answers here. Y can be either minus 1 or plus 1. And here the solutions are, this is a quadratic equation. So when you multiply, you must get plus 1, right? When you simplify it, you must get minus 2. What are those numbers? Right? So it's very straightforward. What are those numbers? When you multiply, you must get plus 1. When you simplify, you must get minus 2. So that is minus 1 into minus 1. Okay. So minus 1 is minus 2. Minus 1 into minus 1 is plus 1. That means this is a perfect square. So this is a perfect square because both the roots are the same. So therefore we can write it as x minus 1 squared. Okay, because x squared minus 2x plus 1. So here we get only one answer, that is x equal 1. Right? X minus 1 equals 0 means x equal 1. So don't get fooled by seeing that they are x and y. So they are ultimately the numbers. So therefore the common one what we need belong to both. So that is 1 plus 1. Okay. So the answer is this is a set containing 1. This is a set containing minus 1 and plus 1. Okay. So therefore intersection must also be written as a set. It's very important. It must be a set. So the intersection between set containing 1 and set containing minus 1 comma plus 1 is set containing plus 1. Okay. So this is the answer. This is not answer. This is not answer. This is not answer. This is not answer. Because intersection will always give you a set, not a number. Right. So that how are you serious? නැත්නම් serious නැතිව මේකටත් ගහලා තමයි එන්නේ. Set එක intersection එකක් තියෙන set එකක් කියලා දන්නේ නැති කට්ටිය. Right. 5 answer is B. C 6. Right. හරි මේක නම් fail වෙලා එන්න පාරේ විලි ලැජ්ජාවේ පණ යනවා. හරි විලි ලැජ්ජාවේ හතර විලි ලැජ්ජාවේ පණ. කුල කණන් ටිකක් හදා ගන්න බෑ. Let Z be an set of integers. Right? Integers means negative and positive whole numbers including 0. Right? Minus 1, minus 0, 1, 2, etc. Minus 2. And A is minus n, where n is a Z be a set of integers and n be set of positive integers. Positive integers means natural numbers. Right? We did those things in semester 1. The first topic in introductory maths. So n be a natural number. So this is my Z and my n is 1, 2, 3, 4, etc. Okay. Natural numbers doesn't have 0 and A is minus n such that n is a natural number. So that means A is minus 1, minus 2, minus 3, etc. 0 is not there. So that is our A. So the question is Z minus n. Remember, Z minus n can be written as something like this. Belong to Z, but not belong to n. Right? So it must belong to Z. Right? Z is set of integers, but it must not belong to n. Okay, then why they have given about A? I think so A is used as a part of the answer. That is why they have given A. Right. So that is why I thought A is not needed. Right. So the Z minus n means all the negative integers and 0, because natural numbers includes 1, 2, 3, 4. You have to get rid of 1, 2, 3, 4, 5. So therefore Z minus n is basically minus 3, minus 2, minus 1, and that's all. Even 0 can't be there. Z minus 0 is also there because natural numbers doesn't have the 0. So therefore 0 will also remain. Minus 1 and 0 because 0 is not removed. Only the natural numbers are removed. 1, 2, 3, 4. So 0 is also there. So here from negative infinity to 0 we have. Right. So then the question answer, definitely it is not Z. Definitely it is not 0. This says 0 union A. What is A? A is minus 1, minus 2, minus 3, etc. Yes, but you have to have 0 also. Okay, 0 is also included by now. So now we have minus 1, minus 2, minus 3, etc. from A. And when you say union 0, now 0 is also added. Therefore, this is the answer. A is not the answer because A doesn't have 0. Okay. And obvious natural number is not the answer. Okay. So the answer is C. And answer is C. Okay. Answer is C. Okay. Not D. Right. 7. Let A and B, I don't know, by going through the first 7 questions, it looks like this paper is easier than previous papers. Okay. Remember, we had a really tough maths database paper. Actually, I told you that that database paper was no, by any means, it was a difficult question paper. It was a fussy paper, right? Fussy කරනවා කියන්නේ අමාරු කරනවා කියන එක නෙමෙයි. Fussy කියන්නේ fussy. හරි? Fussy. ඒ paper එක හදපු lecturer ඉතා fussy විදිහට paper එක හදලා තියෙනවා. හරි? ඒ සාමාන්‍යයෙන් ඒක ඉතා අසාධාරණ වැඩක්. හරි? නමුත් සාමාන්‍ය maths paper fussy කරන්න අමාරු වෙන්නේ සාමාන්‍යයෙන්. Right. So let A and B be two non-empty sets. Right? Two non-empty sets. So A is not equal to 5. B is not equal to 5. And if A is a subset of B, so that means A is inside B. Not proper subset, subset. That means there's a possibility of A equal B also. But හැම පැත්තම පේනවාද කියලා තමයි මේ බලන්නේ. ඔයා නිකන් උඩින් පැත්තෙන් පල්ලෙන් බලලා මොකක් හරි ගහලා එන නේද? ආල්පාරු එක්ක ටිකක් සීරියස් පොරක්ද කියලා තමයි මේ බලන්නේ පේපර් එකක් දීලා. හරි? මොකක් හරි කරලා එන ආල්පාරු එක්ක software development කරන්න බෑනේ. හරි? ඔය පොඩි වැඩක් තමයි කරන්න වෙන්නේ. හරි? චූටි වැඩක්. හරි? ඔය නිකන් මොකක් හරි චූටි වැඩක් කරලා එන ලොකු responsibility දෙන්න බෑනේ එහෙම කෙනෙක්ට. Right. Which of the following must be false? Making අනිවාර්යෙන් false වෙන්න මොකද්ද කියලා අහන්න. Okay. Right. So both are non-empty sets and A is inside B, right? And also there's a possibility of A equal B, right? So that means A is a subset of B or A is equal to B. So that both the possibilities are there. And also both are non-empty sets, right? Both are non-empty sets. Right. First part. A minus B equal 5 must be false and no, na? A minus B, can we say that A minus B equal 5 must be false? No, there's a possibility of A equal B. This possibility is there. Under this possibility, A minus B can be 5. So therefore, we can't say must be false. Must be false means definitely this is correct. There's no way this can be true. Yes, so this can be true. There's a possibility of this can be true, right? When A equal B, because subset, when we say subset, the possibility of A equal B is there. So in that possibility, A minus B is 5. So therefore, we can't say that this must be false. This can be true, right? No. B minus A is 5. No, right? B minus A, again, there's a possibility of A equal B, right? So therefore, we can't say that B minus A is 5. A intersection B, because this can be 5 also, okay? Right. A intersection B is 5. A intersection B is basically A, but they say A is not equal to 5. B is not equal to 5. Okay? So they definitely say that A is not equal to 5 and B is not equal to 5. So therefore, A is inside B. Okay? A is inside B. Therefore, can this be 5? Can this be 5? No way, because A intersection B is actually A, and they say A is not equal to 5. So therefore, this must be false. This must be false because A intersection B is A when A is a subset of B, and they say A is not 5. So therefore, this must be false. Okay. And so this says A intersection B not equal to 5. Right? So it can be 5 as well, because if A equal must be 5, must be false. Not equal to 5. Obviously A cannot be 5. Okay, so therefore A intersection B is not equal to 5 is actually true, not must be false, because A intersection B is 5. Okay, A intersection B is A, right? A intersection B is A. A cannot be 5. Okay, so therefore A intersection B cannot be 5. So therefore this is not must be false. This is sort of must be true, right? So this is not what we need. It says A equal B. Can we say that A equal B must be false? No, there is a possibility of A equal B, because this is not a proper subset, it's a subset. So A equal B possibility is there. So therefore we can't say must be false. Okay. So the must be false situation is A intersection B is 5 because A intersection B is A and they specifically say A is not equal to 5. So therefore this must be false. Right? Answer is C. Answer is C. Okay. මේක තනියෙන් කරන්න කියලා මම කිව්වා හරි. ඒවා ඒ විදිහට කරගන්න නැත්නම් අතරමඟදී දමල ගහලා යන්න. 8. Let A and B be two non-empty disjoint sets. දැන් බලමු කොච්චර අවධානය දෙන්න පුළුවන්ද කියලා යමකට. And again two non-empty disjoint sets. So that means they are disjoint. And also A is not equal to 5, B is not equal to 5. This is my universal set. Two non-empty disjoint sets. Which of the following must be false? What is the true false? Right. A minus B equal 5. A minus B must be 5 because it's disjoint. When it is disjoint, definitely there is no intersection. So therefore A minus B must be 5. A minus B equal 5 must be true. This is must be false. So therefore this is not answer. B minus A. B minus A equal B. Can that happen? No, B minus A can't be B. Yes, right? Because they are disjoint. When they are disjoint, when you remove something here from here, when you remove something here, none of these are common. So therefore nothing will be removed. Right? So B minus A means belong to B but not belong to A. That is B because they are disjoint. Nothing will be removed. So therefore B minus A equal B must be true. Right? B minus A is B because nothing is removed. So therefore this is must be true. What we need is must be false. No. A intersection B is 5. Yes, A intersection B must be 5. Right? Definitely. But this is must be false. This is must be true. No. A equal B. When they are disjoint and when they are non-empty, there's no way A equal B. If A equal B, how can you say that they are disjoint when they are the same? And also they say they are non-empty set. So therefore this must be false. Definitely this is wrong. So that is what we need. Right. Let's look at this one also. This is A minus B. A minus B must be 5. Intersection B minus A. B minus A must be 5. So 5 intersection 5 must be 5. So therefore this must be 5. This must be 5. It says it is not 5. And it says it is not 5. But what we got is it must be 5. Okay, it must be 5. So therefore this must be false. Because what we get is this must be 5. But your answer says it is not 5. No, there's no way it is not 5. Because A minus B is definitely 5. B minus A is definitely 5. Therefore 5 intersection 5 is 5. So therefore this is also answer. Anyone got the answer as D and E? No, must be false is not same as can be false. No. Can be false and must be false are two different things. Right? Can be false means there is a possibility of that happening. Must be false means there's no way it cannot happen. It's always false. It's always false. Right? So completely two different concepts. Right? Must be and can be is two different concepts. So what they ask is must be false. Right? Must be is definitely false. There is no way you can say that this is true. No situation. Right? This will be true. So then only we can say must be false. Right? So the answer must be D and E. D and E as well as A. How come say A minus B equal 5. Non-empty disjoint sets. A minus B must be 5. Yes. So then how can you say it must be false?
A minus B, A, sir. A when W1.
Sorry?
A minus B, A when W1 is.
Sorry. This is not intersection, right? Sorry. Yes. 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 A minus B must be A. Sorry, I made a mistake. A when the අනිවාර්යෙන් A වෙන්න ඕන නේද? So A minus B must be, because you are not reducing anything from A, because B, sorry, I misread the question. So A minus B must be A, right? A. And they say A is not empty, right? So A is not empty. So therefore, A minus B must not be 5, because A minus B must be A, and they say A cannot be, or A is not empty, right? So that means A must not be empty. A must not be 5. So therefore, A minus B must not be 5. Yes, A is answer. Sorry, so I misinterpret the question. Okay, I think I made the same mistake here. B minus A is actually B, right? B minus A is B, because there's nothing you are removing. Okay, so therefore B minus A, I think I told you that B minus A is 5. That is wrong. Actually, B intersection A is the 5. So B minus A must be B. So therefore, this must be true. What we need is must be false. A intersection B, that must be 5. That must be 5. Okay. So here also I made a mistake, same mistake. Here it says A intersection B. A intersection B must be A. So I made a mistake earlier. I think I made a mistake. A minus B must be A. Intersection B minus A must be B. And they say A and B are not 5. Right? A and B are not 5. So A, right? A minus B is A. B minus A is B, and A is not 5, B is not 5, therefore A intersection B cannot be 5. Then we are in trouble. We are in trouble, because this is intersection. A minus B is definitely A. B minus A is definitely B. So then A intersection B, A intersection B. A intersection B is definitely 5, because they are disjoint, right? So therefore, yes, A intersection B must be 5. The answer says is not equal to 5. So therefore, when we know that it must be 5, your answer says not equal to 5. This must be false, right? This must be false, right? Obviously, A cannot be B. A cannot be B, because they are disjoint and non-empty set. Disjoint sets cannot be. There's no way disjoint sets are equal. So therefore, must be false. Okay. A, D, and E. Okay. So initially I made a small mistake. I took A minus B. I just misread A minus B as sort of intersection. I did somewhere in this question. Okay. And also initially this question. Okay. So this is not 5 and 5. A intersection B cannot be 5. Okay. Right. 9. So if I make a mistake, just let me know. Okay. Because I am also human. Right. Let U be the universal set. Okay, so let U be the universal set. Take it as U rather than E. And A be a non-empty subset of it. A. So that is A is subset of universal set. Non-empty set. And A is not equal to 5. Which of the following must be false? That means definitely it is false. Okay, definitely it is false. First one. 5 must be subset of A. Of course, any set can be written as subset of A. Even if A is a 5, it is still valid, because 5 is equal to 5. And for any set, 5 is a subset, because nothingness can exist anywhere. Okay, right. So therefore, this must be true. This is must be true. So what we need is must be false. So therefore, this is not answer. Right? A complement, and they say A is non-empty set. If A is non-empty set, A complement is also, so something like this. Okay. So it says A complement is U. No, A complement is U minus A. Right? U minus A, and they say A is non-empty. When A is non-empty, U minus A is also, we can't say no, U minus A is U. Right? U minus A is, you can't say U minus A is U because A is non-empty. When A is non-empty, it must be something, something removed from U. Something removed from U because A is non-empty. So therefore, this must be false. Make a කොහෙත්ම වෙන්න බෑ. කොහෙත්ම වෙන්න බෑ because A is non-empty. So this is answer. හොඳට කල්පනා කරන්න. A complement is U minus A. When A is non-empty, your A complement must be having something less, something removed from U, and definitely. So therefore, when someone says A complement is U, this must be false. Okay, this must be false. Next one. දැන් මේ වල තියෙනවා නැහැ සියල්ල ඇතුලේ තියෙනවා නේද එළියේ තියෙනවා දෙකටම අයිති එකකට හරි අයිති කියන කතන්දරේ තේරෙනවද කියලා මේ බලන්න. හරි මේක සමාජයේ ජීවත් වෙන්නත් බෑ මේක කරගන්න බැන්නා. හරි ඒකනේ ගිහිල්ලා තමන්ගේ වත්තේ තියෙන මායිම අනිත් පැත්තෙන් ගහලා දාන්න. මොකද එයා හිතනවා නෑ එහෙම කරාට අවුලක් නැහැ කියලා. හරි. ඒක නේද තක්කඩිකම් වෙන්නත් පුළුවන්. සමහරට ලොජික් තොට එන්නකම් වෙන්නත් පුළුවන්. Right. A complement is not equal to U. So A complement or A bar is, yes, A bar cannot be U because A bar is something less than U. Right. So this says A complement is not equal to U. Yes, definitely A complement is not equal to U. Okay. Because A complement is something less than U. So therefore this must be true. Right. This must be true. So this must be true. So what we need is must be false. So therefore this is not answer. A complement is U. Must be false. A complement is U. A complement must be something less than U, right? So something less than U. So therefore this must be false, right? Right. So this we take it as answer, right? We take it as answer. So this is not answer. This is not answer. It must be false and then answers get pattern. So this is answer. Right. What about this? A complement is a subset of U. Yes, definitely. A complement or A bar must be a subset of U. Right. So it must be. Can I say that it must be false? No. A complement must be always within the, because we are not interested in anything other outside U. Okay. So therefore this must be true. So therefore it is not answer. What we need is must be false. A complement is proper subset of U. Of course A complement must be a proper subset of U, or yes, it must be proper subset of U because A is not an empty set. Actually this is, but this is, you can't say this is false, right? This is correct. So correct answer means wrong because what we need is must be false. Right? So this is correct. Right? A complement must be with inside U. A complement must be subset of U. Right? Yes, A complement cannot be U.
A complement cannot be U. Must be false.
Which one you are referring? Which answer?
D1. A complement is
A complement must be subset of U. A complement is out inside U, right? A complement must be inside U. So therefore it is correct. How do you say that it can be true? It can be false. Must be false.
Can be false.
Huh?
It can be false. Okay.
Yeah. It can be false. Do you see any reason why A complement is subset of U can be false? Under which condition A complement is subset of U can be false? I don't see.
Okay.
Yeah, I don't think, right? So this must be true.
I agree with this.
Yeah, it must be true, I think, right? So therefore what we need is must be false. So this is the one we can filter out for must be false. Let's double check. Must be false. A complement equal U. No, A complement cannot be U because A is not a empty set. So therefore something must be reduced from U. Okay. So therefore definitely B is the answer. Okay. So 9 answer must be B. Yes, 9 answer is B. 10. I don't know. I told you that this is the most interesting subject in your BIT. Most interesting subject, and you don't have to memorize or whatever, right? Make them පාඩම් කරලා මේක කොට දාන්න බෑ maths. හරි? maths කියන subject එකෙන් පාඩම් කරන්න බෑ. maths කියන subject එක ඇඟේ තියෙන්න ඕන දැන්. හරි? ඒ practice කරන්න ඕන sets පාඩ කර කර. හරි? Right. So 10. හැමතිස්සෙම කල්පනා කරන්න ඕන. හරි? හැමතිස්සෙම කල්පනා කරන අපි ඉන්නේ මම ලංකාවේ මිනිස්සෙක්. ලංකාව කියන IQ එක පහළින්ම තියෙන රටක්. හරි? පතුලෙම තියෙන රටක්. ඒ රටේ ඉන්න මම පරිස්සමෙන් තමයි මේ sets question කරන්න ඕනේ. මොකද මම නම් නිතරම එහෙම හිතනවා. මොකද ඒක තමයි reality එක. ඒකට අපි නිතර කතා බහ කරන්නේ ඒ average IQ තියෙන කට්ටියත් එක්ක. හරි? හොඳට මතකද ලංකාව කියන IQ වලින් ඉතාලම පතුලේ ඉන්න රටක්. ඉතාලම පතුලේ ඉන්න රටක්. හරි? අන්තිම මම හිතන්නේ 20 විතර ඉන්නේ. හරි? අපිට වැඩි ඉස්සරහින් ඉන්න බංග්ලාදේශයේ අප්‍රිකානු රටවල් සෑහෙන ප්‍රමාණයක්. ඔයගොල්ලන්ට ඔය ඉස්කෝලේදී කියන්නේ නැහැ. ඉස්කෝලේදී රෙද්දක් ඇඳගෙන කියන්න බෑනේ පඩි ගන්න ගමන්. හරි? ඉස්කෝලේදී ලෝකෙන් උතුම් රට කියලා කියනවා ඇති. Right. Let x and y be any two non-empty sets. Again, two non-empty sets. If x is a proper subset of y, so that means x is definitely inside y, and there's no way x can be y also. Right? There's no possibility of x equal y, and x must be within y. Which of the following must be true? X is a subset of y. Obviously, when something is a proper subset of y, when x is a proper subset of y, we can always say x is a subset of y. Definitely. Right? Definitely. Because this is more general statement than this. And this statement covers this statement as well. So whenever this happened, this happened. But whenever this happened, we can't say this happened. But whenever this happened, this happened. If I say this is my A and this is my B, A implies B. But we cannot say that B implies A. Right? So this is true. So therefore, when this happens, this must be true. Right? So next one must be true. What we are looking for. Y is a subset of X. No. How can Y be a subset of X when X is a proper subset of Y? Right? So this is must be false. Right? Must be false because this equal mark is also not there. This is not. Y minus X. Y minus X. Remember, X and Y are non-empty sets. So that means there must be at least something reduced from Y. Right? Y minus X will be 5 only if X equal Y. But there's no possibility of X equal Y because X is a proper subset of Y. Okay? So therefore, Y minus X cannot be 5. Cannot be 5. There's no way Y minus X can be 5. Okay? So what this says is Y minus X is not equal to 5. Yes, Y minus X must be not equal to 5 because X is a proper subset of Y means X and Y cannot be 0. Same. If X and Y if X and Y equals 0 only, this will be 5. So we know that X and Y are not same. So therefore, definitely Y minus X cannot be 5. Must be true. Right? Must be true. So this one says Y is a proper subset of X. No way. Right? No way. X is not equal to Y. So definitely, because when X is a proper subset, there's no way X and Y is same. Yes, must be true. Must be true. Okay. So the answer is ACE. Anyone got the answer ACE for 10th? Why not A?
Why? So, why so A is the answer? Can you explain?
A is the answer. Okay. So now this says X is a proper subset of Y. Proper subset means X is inside and there's no chance of X equal Y. Okay. So X is a subset of Y means X is a proper subset of Y or X is equal to Y. Now we know that X is a proper subset of Y. So therefore this is only true. True or anything is true. Right. So true or remember A plus A plus 1 is 1. Right? A plus 1 is 1. So therefore this is true. Because X is a subset of Y means X is a proper subset of Y or X equal Y. So therefore when this is true, right? Because it is given. So therefore true or anything, something is true. So therefore this must be true. Okay. Right. So the answer must be A, C, E. Right. A, C, E. Always a general statement. Whenever specific statement is true, its general statement is always true. Because general statement covers the specific statement. Okay. But not the other way. Right? When then general statement is true, you can't say that specific statement is always true because we never know. Right. So let's move on to question 11. Let A, B, and C be three non-empty sets. Which of the following are false? Okay. Non-empty sets A, B, C. Okay. So then there are so many possibilities. Okay. So many possibilities are there. Three non-empty sets. Which of the following are false? Okay. In general, false. Okay. So there's a possibility like this. And there's possibility like this. And so many other possibilities are also there, like these two are intersection, but this is intersecting like this, or this is away. So many possibilities. Okay. Only thing is they are non-empty sets. Which of the following are false? Right. So this one, and see whether these are the general statements, because general statements are true for any scenario. Right? So A union B intersection is what? A union B intersection A union C. Right. So this is a general statement. Right? A union B intersection C is A union B intersection A union C. That is one of the set rule. Right? So set rules are true. So therefore this is true. What we need is false. This is union and intersection again. A union B intersection. Again it says A union A. Sorry. So this is, they have swapped this. Right? A union B is there. A union C is there. Right? So they have swapped this. Of course, X and intersection Y is same as Y intersection X. So therefore this is true. What about this? A union B intersection is A union. This is B intersection C. This is C intersection B. Of course, A intersection B is same as C intersection B. So therefore this must be true. Okay. What about this? A union, right? B intersection C. Again, they have swapped this. A they have taken there, and B intersection they have taken here. So this must be true. This is one of the rule. One of the rule means X intersection union Y is same as Y union X. Right? So you have to think like blocks. Block with your non. What about this? A union B. If you expand this, it must be A union B intersection A union C. But what we have got is something else. So therefore, let's in general, let's draw it and see. It looks like not a rule, but let's see whether it's anyway wrong, because we have to check whether it's false. Let's take a general scenario like this and see, at least for one scenario. A, B, C. A in union, B intersection C. It must belong to A, right? A, or it must belong to B and B intersection C. So that is, this is A. B intersection C is this one, so therefore this one is also added. Okay, A union B intersection C. What about this? Right, A union B intersection C, that is this area. Now let's double check this one. A intersection C, you have to have the same place, ABC. A intersection C is this area. Union A intersection B is this area. Okay, so this is not going to be same as this one, right? So therefore this is false, right? So we already found that this is false for this scenario also, so therefore this is false. Okay, so the answer must be D, right? 11D. Yes, answer must be D. Right, 12. Let A, B, and C be any three non-empty sets. Which of the following is are true about A? True about A. Right? A, B, C are any three non-empty sets. Okay. Which of the following is are true about A? Right. So again, it can be so many possibilities are there. It can be something like this. Right. It can be something like this even. Right. And some other combinations. Right. A is B complement intersection C. Let's use the general scenario. Not belong to B and belong to C. So that is something like this. Not belong to B, but belong to C. Union B intersection C. B intersection C is this area. So that is basically C. That is basically C. Okay, so we can't say that that is A. Okay, so this is wrong. What about this? Let me delete this and draw it again. Okay. Must belong to B and not belong to C. Must belong to B and not belong to C. So that is B is also there. It can't be A because this is union. Okay, A වෙන්න බෑනේ මේ පැත්තත් partly දැන්ටම partly ඉවරයි නේ. ඔකට union එකත් තව එකතු කරනවානේ. So this can't be. ටක් ගාලා අයින් කරගන්න. So ඒක ටක් ගාලා අයින් කරගන්න. So this can't be the answer. Here C intersection A. C intersection A means belong to C as well as belong to A. So that is this part. Okay, C intersection A. Union A intersection C complement must belong to A, right? But not belong to C. That is this one. That is A, right? This one union, this one is A. This is correct, right? This is correct. What about this? A intersection B is B part. Okay, let's draw it again. A, B, C. Right. A intersection B is this part. Must belong to A, but not belong to C. Right? Must belong to A. A belong to A and not belong to B. Which one I'm looking at? Right. A intersection B is there. Okay. Must belong to A and not belong to B. So that is this part. That is again A, right? That is again A. Okay. So what about the last one? Let me draw it bigger. Make sure you draw it bigger, otherwise you will have a lot of issues. Again, use the same positions. A intersection B, that is this part, belong to B and not belong, that is something else. So this can't be. So the answer is B and E. Right? B and E. Now it's almost 55 minutes and we have done only 12. එකත් මතක තියාගන්න. ඔක්කොම 40ක් තියෙනවා. හරි? 40ක් තියෙනවද? කීයක් තියෙනවද? Time කරන්න ඕන exam එකේ අනිවාර්යෙන්. Right, 40 question means by this time I should be around 20, right? I should be around 20, but still I am around. Now you can see, so එක තමයි time කරලා exam එක කරන්න කියන්නේ. So the exam එකේ අනිවාර්යෙන් ඔය process එකේ speed එක බලනවා. Right. හැබැයි මැද තියෙනවා ටිකක් lazy question. වෙලාව අඩුවෙන් යනවා. හැබැයි සාමාන්‍ය set තමයි අඩුවෙන් වෙලා යන්නේ. දැන් වෙලාව වැඩියෙන් යනවා තියෙනවා. Let A and B be two sets. Which of the following is are correct? Which of the following is are correct? A union B is X such that X is a member of A and X is a member of B. That is A intersection B. No. A intersection B, X is a member of A and X is a member of B. Yes. A union B is a subset of A intersection B. Obviously, so oh no, other way around, right? Because A union B is this one, right? You can't say that A union B is inside A intersection B, which is this part. It is other way around. So therefore, this is wrong. What about this? And this is by definition, right? Correct. A union B is belong to A or belong to B. So this is intersection must be and. Answer is B and C. B and C. Now speed up කරා මොකද පැය දෙකකින් කරන්න පේපර් එකක් නේද? නැත්නම් වැඩක් නැහැ. Let P and Q be two propositions. Okay, propositions. Which of the following propositions is are logically equivalent to P if and only if Q? Right. So we did those things. Okay. P if and only if Q. So you must know the truth table of P if and only if Q. Then you have to double check which one gives the exact truth table. This is time consuming. I'm just keeping this question for last. Right. ඔයගොල්ලෝ කරන්න යන්න එපා. ඔයගොල්ලෝ කරන්න ගියොත් නාන්න වෙන්නේ හරි පෙරේතකමට. කරන්න පුළුවන්. හරි. truth table අඳින්න බෑ. Let's keep it. මට අමතක මතක් කරන්න. 15. Again we have to draw the truth table. Let's keep it. truth table අඳින්න තුව කරන්න අමාරුයි. Right. මේක එච්චර අමාරු නෑ. logic question ටිකක් වෙලා යනවා. හරි. අපි ওই ටික තියලා අපි ගිහිල්ලා අන්තිමට කරමු මේ ටික. පොද වෙලා යන questions එනවා. මේ තියෙන lazy අපි 21ට වෙනකන් තිබ්බා. 21ට වෙනකන් තිබ්බා. හරි. අපි 21 ඉඳලා ආයි කරනවා දැන් 20ට වෙනකන් තිබ්බා. right. මොකද වෙලා යනවා මේ question කරලා truth table අඳින්න බෑ. බොහෝ විට හරි. Right, let Px is x is less than or equal to 0 and Qx is x is greater than or equal to 0. Right, so let's draw it. This is my number line. Px is s is less than or equal to 0. Less than or equal to 0 means this area, including this. So this is my Px. And let's use another color for Qx. Qx is x is greater than or equal to 0. That means this part and this part. So blue is in both sides. And blue is in both sides. Red is in both sides. Okay. Right. Define on Z. Z is integers. So that means you don't have to take the negative fractions, right? Integers. Okay. That is negative and positive, all numbers and 0. Which of the following proposition is are true? Right? Is are true. Proposition is are true. All x, px or qx. Is it correct? Yes, right? If you take x as a integer, because it says is x defines on integer, all the integers must belong to either px or qx. If you take 0, it belongs to both, but that is fine because when we say or, both are also okay. So therefore, this is correct. All x are either px or qx. All x are px and qx. No. Only 0 is px and qx. Only 0. So then how can you say that all x are px and qx? No. P0 and Q0. So Px is this. When we say 0, 0 is less than or equal to 0. When x is 0, 0 is less than or equal to 0 is correct. So this is true. Q0. When x is 0, x is greater than or equal to 0. So 0 is greater than or equal to 0. Obviously 0 is greater than or equal to 0. So therefore true and true is true. Right? So therefore this is correct. Then what about this? We know that P0 is true. Q0 is true. Not true is false. Not true is false. So therefore false or false is false. So what we need is true statement. This is false or false is false. This is not answer. X is x, px and qx. Again, px සහ qx කියන දෙකම වෙන එක්කෙනෙක් හරි ඉන්නවා. ඔව් එක්කෙනෙක් ඉන්නවා. කවුද? 0. right? එක්කෙනෙක් හිටියොත් ඇත්ත යා x is කිව්වම ලක්ෂයක් ඉන්න තැන එක්කෙනෙක් තොප්පි දාගෙන හිටියොත් එමාට ගිහලා කියනකොට අන්න අතන තොප්පි දාගත්ත කෙනෙක් ආයි ඉන්නවා කියලා. හරි? එක්කෙනෙක් හිටියම හොඳ නෙමෙයි. අතන ඉන්න සමහරු තොප්පි දාගෙන ඉන්නවා කියලා ඔයාලට කියන්න පුළුවන්. ලක්ෂයක් ඉන්න තැන එක්කෙනෙක් තොප්පි දාගෙන ඉතියි. කවුලක් නැහැ. ඔයාලට ගිහලා කියනවා අතන exist වෙනවා කියලා තොප්පි දාපුවා. Yes, there's one possibility, therefore this is good enough to, right? So x is x, px and qx, correct. Answer is A, C and E. 21. A, C and E, correct. Okay. Thank you. Right. 22. Let Px be a predicate defined on domain D. Right. Domain D. Which of the following is equivalent to not all x are Px? Right. That means not all x are Px. How do you say that? Or හැම කෙනෙක්ම Px කිව්වොත් ඒක වැරදි කියලා කියන්නේ. Not all x are Px. Right? Not all x are. ආයි කියවන දැන්. දෙතු පාරක් කියවන්න. ආයි කියවල බලන්න. ආයි කියවල බලන්න. Not all x are Px. දැන් මේක ෆසි. මේක මටත් වරදින්න පුළුවන්. මම මනුස්සයෙක්නේ. හරි? ඒකයි මම ආයි මේ කියවල ඔලුවට ගන්න ගන්නේ. Not all x are Px. All x are Px කිව්වොත් එහෙම වෙන්නේ නැහැ. එහෙම නැහැ කියලා කියන්නේ. ඒ කියන්නේ all x ලා Px නෙමෙයි කියලා මගේ ඔලුවට නම් වදින්න මේක. හරි? මම හිතන්නේ මේක අපි වරහනක් දාගත්තොත් හිතේ. Not all x are Px. හැමෝම Px වෙන්නේ නැත. ඒ කියන්නේ Px නොවන අය එක්කෙනෙක් හරි ඉන්නවා. හරි Px වෙන අය එක්කෙනෙක් හරි ඉන්නවා. right? මේක අපි බලන්න මේ කියන්නේ මෙයා not all x are Px නැත්නම් not all x are Px කියලා. Not all x are Px. Not all x are Px කියන්නේ not all x are Px means at least one Px is there, right? So that means exist x Px වෙන්න ඕනේ නේද? Exist x Px වෙන්න ඕනේ. So Px are not existing, so this can't be. Not Px. All x are not Px. No, there must be at least one Px. That is why we say not all x are Px, right? So this is also wrong, right? All x are not Px. No. Not Px are not all x. Not Px are not all x. Not Px exist. Not all x are Px. And Px no in. Yes, not Px exist. Correct, right? So So when we say not all x are px, that means there must be someone, at least one not px are there. So that is why we say not all x are px. හරි හැමෝම px කියන්න බෑ කියන එකේ තේරුම තමයි මොකද්ද? not px ආ එක්කෙනෙක් හරි ඉන්නවා. So this is the answer for me. Okay. Not px are not existing. නෑ not px ලා ඉන්න ඕනේ. ඒකයි මෙහෙම කියන්න බැරි. හරි ඒකයි මෙහෙම කියන්නේ. So this is not answer for me. Not px are all. So I think this is not relevant. Right? Because මේක අරගෙන අදාළ නැහැ නේද? So therefore let's not take that. So this is relevant for me if I have interpret this properly. Okay. Let's double check the answer first. Okay. Because this is a fuzzy. Yes, A is the answer. Okay. So how do you interpret this? So if you forget about the not, that means all x are px. Right? If you forget about this, you can first interpret like this. All x are px. But now it says not. So that means not all x are px. That means at least one non-px is there. So that is what he said, not px are exist. So that is why we can say like that. හරි ඔය ඇවිල්ලා කියනවා එතන ඉන්න ඔක්කොම අල්ල නම් තොපි දාගත්ත අය නෙමෙයි. ඒ කියන්නේ මෙතන තොපි දාපු එක්කෙනෙක් හරි ඉන්නවා. තොපි දාපු නැති අය එක්කෙනෙක් හරි ඉන්නවා. හරි එක්කෙනෙක් හරි ඉන්නවා. හරි මේකෙන් ගන්න පුළුවන් එකම කතන්දරය ඔක තමයි. හරි. So answer is A. So that is little bit fussy. Right? Anyway, your A plus is 90. 90 නේද? 90ක් දාගන්න ඔය එක question එකකින් ඔයාලට A plus එක ගලව ගන්න ඕනේ නැහැ. හැබැයි මේකත් හරි කල්පනා කරොත් ඔළුවට ගන්නත් පුළුවන්. හරි. Right, 23. Let x 346 y 1289 blah blah blah. Which of the following belong to alpha? Okay, so this is my alpha. How do you get the alpha? A be such that A must be less than or equal to B and A is belong to X and B belong to Y. That is easy, right? So what you need is all the ordered pairs where first one must be from here, second one must be from Y sets, and always your A must be less than or equal to B. All the ordered pairs you have to write. First one. So X must be, A must be less than B, less than or equal to B. Okay. So therefore 3 1 we can't say, 3 2 we can't, 3 8 yes, 3 8 because 3 is less than or equal to 8. Then what about 3 9? Yes. Okay. So then 4 8 yes, and 4 9. Then 6 8 and 6 9, right? 6 8 and 6 9. That's it, right? 3 4 6. Yes. Yes.
So intersection A.
A is less than or B and A is a member of X and B is a member of Y. What do you mean by intersection A? You interpret it like this? No. You have to take it like this. You have to take this statement, right? And this statement and this statement, right? A is less than or equal to B and A is a member of X and B is a member of Y. I think your confusion is you take it as A is less than or equal to B and A. Right, B and A. No. Okay. Because you can't say something like B and A. Right. So it must be sets. Right. So this is set, this is set, this is set. So okay. Right. So then the answer must be which of the following belong to alpha? 3 4. No, 3 4 is not there. Anyway, 4 is not here. 9 9. No, because first one must be from here, second one must be from here also. 4 2, no. 2 3, no. 6 8, yes. Answer is E. 23 answer is C. Right, 23 answers. I hope you got the that confusion resolved. So this is and is this one and this one and this one. Okay. Right, 24. Let alpha and beta be two relations defined by alpha a comma b. A is greater than or equal to b, and A and B are, again, this is, you have to subdivide here, right? A and B are member of Z, that is integers. A must be greater than or equal to B. Okay, A must be greater than or equal to B, and this is N. Let alpha and beta be two relations defined by alpha AB blah blah blah, and beta A comma B such that A squared equal to B squared and A and B are integers. Okay, which of the following is are true? Symmetric, transitive, reflexive, blah blah blah. Okay, so this is little bit challenging, right? So you need all the numbers integers where first number must be greater than or equal to second number. First number must be greater than or equal to second number. Okay, so here you need A squared equal B squared, where A and B are integers. So A squared equal B squared is something like 1 squared equal 1 squared. Okay, 2 squared equal 2 squared, right? But not only 1 and 1, you can take even 1 and minus 1, because 1 squared equal minus 1 squared, right? 2 squared equal minus 2 squared, because 2 squared is also 4, minus 2 squared is also 4. Then 1 squared minus 1 squared equal 1 squared. That is minus 2 squared equal 2 squared. Similarly, minus 1 squared equal minus 1 squared, or minus 2 squared equal minus 2 squared. So look at all those 4 possibilities. Okay, all these possibilities are there here. That means the same numbers 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Not only that, 5, 5, 5 minus 5, minus 5, 5, right? Minus 5, minus 5. All these possibilities are there for all the numbers. Yeah, and also 0, because 0 squared equals 0 squared, right? 0, that is also there. Okay, so 0 is the special case, because there's nothing called minus 0. Then, so we have to take only that kind of numbers, that is 1, 1, 2, 2, 3, 3, 4, 4, or 1 minus 1, minus 1, 1, or minus 1, minus 1. Okay, but then it has to, all those in possibilities, infinite number of possibilities are there here. Then here it says my B must be, A must be greater than or equal to B. A must be greater than or equal to B means we can't take, for example, if you take this one, we can't take minus 2 and 2, because minus 2 is not greater than or equal to 2. Okay, and also can we take 2 and 2 is okay. Okay, minus 2 and minus 2 is also okay, because equal. 2 and minus 2 is also okay, because 2 is bigger than minus 2, but you can't take minus 2 and 2, because then A is not greater than. That is the only possibility you can't take. Okay, so it's very tricky scenario. Okay, so then we have to now double check these properties. For example, if you take 2, these things are there, right? So now let's look at only 2. This is actually very difficult question. 2 to minus 2, 2 to 2, right? But not minus 2 to 2, 2 to 2, and minus 2 to minus 2. Now you can see that 2 to minus 2 is there, but minus 2 to 2 is not there. So therefore, definitely it is not symmetric. So therefore, this is wrong. They separately they ask, right? They separately ask. Sorry, they are separately asking. Okay, so therefore we don't have to look at both together. Okay, so we have to look at separately. So sorry, I made that question extra difficult. So you don't have to look at both. You look at this separately. You look at this separately. Okay, so then it's easier, right? It's easier now. Okay, so it's easier now. I thought we had to combine those things, right? So let's look at the second one. So second one we have, for example, 2, 2. I'm just taking 1, right? 2, then it's applicable to 3, 4, all the other things. Okay. I'm just taking 1 to get a feeling about it. 2, 2 is there. 2 minus 2 is there. Minus 2 minus 2 is there. Minus 2, 2 is there. Because then a squared equal b squared. So similarly, we will have, right, 3, 3, 3 minus 3, minus 3, 3 minus 3, minus 3. Okay. So this is definitely reflexive. 2 to 2 is there, minus 2 to minus 2 there, then 3 to 3 is there, minus 3 to minus 3 is there. So therefore this is reflexive. Right? Reflexive. What about transitive? Yes, when 2 to minus 2, minus 2 to 2 is there. So this is transitive. So this is symmetric. Symmetric. Okay, this is symmetric. Is it transitive? So transitive means when A to B and B to C, there must be A to C. Okay, so A to B and B to C, there must be A to C. Okay, so do we have 2 to 2 is there, 2 to 2 is there, 2 to minus 2 is there, and then 2 to minus 2 is there, right? 2 to 2 is there, 2 to minus 2 is there, so then 2 to minus 2 is there, right? So we can say it, right? Transitive. The transitive property is not violated. Maybe transitiveness is not related, but it's not violated, right? So therefore I can take transitive also, right? So this is taking a lot of time anyway. Anyway, we do it. Exam again, my question right. So then about this one, A must be greater than or equal to B. A must be greater than or equal to B. So that means if you take something like 1, you have to say 1, 1, 1, 2, 1, 3, etc. Right? So then something like 2, 2, 2, 2, 3, 2, 4, etc. 1, 4 is also there. Okay. So it is it reflexive? Yes, because 1 to 1, 2 to 2, 3 to 3 is there. So therefore this is reflexive. Right? Reflexive. But it is not symmetric because 1 to 3 is there, but there won't be 3 to 1. So not symmetric. Not symmetric. Okay. Transitive. If 1 to 2 and 2 to 3, there will be 1 to 3. Yes, transitive, right? Just take an example and think about it, right? If 1 to 2 is there and 1 to 3 is there, sorry, 1 to 2 is there, 2 to 3 is there, then 1 to 3 is there. Yes. So then let's look at the answers. Both alpha and beta are symmetric. No, this is not symmetric. So this is wrong. Alpha is not symmetric. Yes, alpha is not symmetric. And beta is symmetric. Yes, beta is symmetric. Correct. Both alpha and beta are transitive. So this looks transitive, but this is not violating transitiveness. Therefore, I will take it. Okay. But this can be a little bit, because it's not violating, I will take it. Okay. When A to B and B to C is there, A to C must be there. Yeah, it's not violated, right? Yes. Both alpha and beta are reflexive. Alpha is reflexive, beta is reflexive. Yes. B is correct. C is reflexive. Alpha is reflexive. Yes. And beta is not reflexive. No, beta is also reflexive. So I will take the answer as BCE. Okay, BCE 24. BCE, correct. Okay. So here, since transitive property is not violated, I took it. Actually, there's not something like A to B and B to C goes A to C, but it has not violated. Okay, it has not violated. Right. So therefore, answer is correct. Our one is correct. B, C, and E. Okay. Right. So let's look at the 25th one. Right. Let alpha be a relation defined on Z. Z means integers. Okay. Alpha is A comma B such that B is A plus 2. Right. ඒ කියන්නේ y සමානයි x ධන දෙක රේඛාව මත තියෙන ලක්ෂ ටික ඔය අහන්නේ. Right. And A B are integers. Find alpha inverse. Right. So alpha inverse means the inverse of this function. So that's very easy. Right. If you take this as what පුරුදු විදියට ගත්තොත් y equal x plus 2, what is the inverse? You take x other side, x equal y minus 2, then you just write it whatever x or y equal x minus 2. So therefore inverse will be, alpha inverse will be y equal x minus 2. Okay, it doesn't matter whether it's y o, x o, k o, l o, m. Okay, right. So now let's look at alpha inverse is xy such that y equal x plus 2. No, x equal y minus 2. Yeah, that is fine. Whether you say x, if you say x and y, no, if you say x and y, yes, that is fine. No, if you say x and y, it must be y equal x minus 2. So therefore this is wrong. Because if you say x and y, it must be y equal x minus 2. Okay, so therefore this is wrong. X and y, x equal y plus 2. X equal y plus 2. Okay, let's keep it. X and y such that y and x is in alpha. Yes, that is the definition of inverse. What is the inverse? Reverse. If y and x is in the alpha, the x and y are the inverse. Because if 5 to 10, the inverse must be 10 to 5. So this is the definition of inverse. What about this? Y equal x minus 2, right? And x and y are integers. Yes, right. That is correct. So that is correct. What about this? This says x equal, yes, so rather than writing, so this is x, if it is x and y equal x minus 2, right? Y equal x minus 2, x and y equal x minus 2 is same as x equal y plus 2, right? Yes. So what if y equal x minus 2, we can write the same thing as x equal y plus 2, right? So therefore this is also correct, right? Yeah, this is also correct because this is y is here, x is here. Yes, this is also correct. That is a tricky one, right? Because they have changed the xy, so therefore that is also correct. Okay, so therefore answer is B, D, E. B, C is not answer, D and E. Okay, so think about it. Especially think about this one. This is a very tricky one. Okay. Right, 26. Let alpha be a relation defined on a non-empty set D such that it is reflexive. Which of the following is are true? Right. Alpha be a relation defined on non-empty set D. Just let me, whether I'm recording this. Yeah. Let alpha be a relation defined on a non-empty set D such that it is reflexive. Which of the following is are true? Right. Reflexive means always A to A, B to B, C to C must be there. If there's a value in the domain, it must be mapped to itself. Anything else can happen. We don't care, but this must be satisfied. Okay. Right. Possible. All xx must be in the alpha. Yes. Why do you say alpha? Yeah, let alpha be a relation. Okay. Right. So therefore, xx must be in the alpha. Correct. That is correct. Okay. Domain is your D. What about this? All x is in the domain of alpha and xx must be in the alpha. Yes, right. So that is also correct. Domain එකේ ඉන්න ඕන x සහ xx alpha ගේ ඉන්න ඕන. මෙතන domain එකේ ඉන්නවා කියන කතාව නෑ නේ all x කියලා තියෙන්නේ. domain එකේ ඉන්නවා කිව්වොත් වැඩි හොඳයි. all x නේද? all x කියනට වැඩි හොඳයි. Let alpha be a relation defined on non-empty set D such that it is reflexive. So therefore I think this answer is better than this answer because this one is not referring to the domain. It says in general, right? Because they specifically say your alpha is defined only for D domain D. So therefore this is better than this one. Okay. All x. Okay, let's look at this. All x, all y, xy is in alpha. If xy is in alpha, it implies yx is also in alpha. So that is not reflexiveness, right? So that is symmetricness. Xy when xy is there, yx must also be there is not reflexiveness, that is symmetric. So therefore this is definitely not the answer. Exist x. X is in the domain, xx is, no, it just says exist x. No, not exist x. For all x in the domain, it must be mapped to itself. Therefore, this is not good enough. This is definitely not good enough. What about this? Make a transitive when when xy is in alpha and zy is in alpha, it implies xz is in alpha. එකත් හරියට ලියලත් නෑ. When zy is in alpha, එකත් හරියට ලියලත් නෑ. හරි. මොකද it must be when xy is in alpha and yz is in alpha, then xz must be in alpha. So therefore this is even not the definition of transitiveness. So therefore this is anyway wrong. So this one is the best answer. So this is loose because they are not talking about the domain because they say set D. So therefore I will go only for E. Right? Only for E. I'm because C is little bit lacking this domain. Okay, 26 I will go for E. Yes, so examiner has also taken E. Okay, right, 27. Then lazy again, yeah, lazy again, yeah, pretty good. දැන් පේපර් එක කරද්දි තේරෙයි කොයි ඒවටද වෙලා අඩුවෙන් යන්නේ කොයි ඒවටද වෙලා වැඩියෙන් යන්නේ. දැන් තේරෙයි ටිකක් මේ රිලේෂන්ස් ක්වෙස්චන්ස් වලට වෙලා වැඩියෙන් යන්නේ තියෙන chance එක අඩුයි. රිලේෂන් වල පොඩි ඉලක්කම් ටිකක්නේ තියෙන්නේ. හැබැයි සෙට්ස් වලටත් සාමාන්‍යයෙන් වෙලා වැඩි යන්නේ නැහැ. හැබැයි ලොජික් වල අර ට්‍රූත් ටේබල් අදින්න වෙන ක්වෙස්චන්ස් තියෙනවා. ඒවට වෙලා යනවා. හරි. අන්ද ලොජික් අදින්න කරන්න. probability වෙලා යන්නේ නැහැ. හරි. probability also it take less time. Counting definitely take less time. Okay, either you do it or not. Okay, right. 27. Let alpha be a relation defined on A xy. Be alpha xx yy xy yx. Find y alpha. Hari. Tag කරලා අන්තිමට මේ විදිහට xx yy. Then this is my x and y. xy xx yy xy and yx. Okay, so that means it's symmetric, reflexive, transitive is not violated, therefore we can take transitive also, right? So what we need is y alpha. y ගෙන් කාටද ගිහලා තියෙන්නේ? y ගෙන් y ට ගිහලා තියෙනවා, y ගෙන් x ට ගිහලා තියෙනවා නේ. From y to y and y to x. So therefore x and y, right? X and y. Y to y, y to x. So answer must be C. C. E also. ඕනේ ඒක දැක්කේ නෑනේ. ඔන්න දැක්කද? එක්සැමිනර් අපේ මංකොල්ල කෑව ලකුණක්. හරි. මංකොල්ල කෑව අපිව රවට්ටලා. Yes, xy is my A. So therefore A is also answer. හරි. ඔන්න ඕවා තමයි කරන්නේ. ඒව තමයි තමන්ට තමන් ගැන දුක හිතන දේවල් නේ. නිකන් ගන්න තියච්ච ලකුණක් නැති කරගත්තා. හරි. Right. So that is also answer. Right. 28. Which of the following is are equivalence relations? Right. Equivalence means it must be symmetric, reflexive, and transitive. Right. Right. අපි break එකක් අරගෙන මේ ටික කරමු. Right. So let's continue. Right. So the next question. right? So this one, right? 28. Let me delete this. Which of the following is our equivalent relations? Right, first one. So it's again a little bit time consuming question. A is less than or equal to B. So obviously when A is less than or equal to B, we know that it is equivalence means symmetric, reflexive and transitive. When A is less than or equal to B, something like 2 to 3 can be there, but there's no 3 to 2. So therefore it is not symmetric. Symmetric must be happen for all pairs. When 2 to 3 is there, 3 to 2 must be there. Therefore this is not symmetric. Therefore this we can't take. What about this? A squared equal B squared, we already discussed, right? So for example, 2 to 2, minus 2 to minus 2, 2 to minus 2, minus 2 to 2. So those kind of possibilities are there for 3, 4, 5, 6, etc. Right? And only for 0, it is 0 to 0. Okay. So definitely it is symmetric. And it is reflexive. When 2 to minus 2 is there, minus 2 to 2 is there. And also it's transitive, right? Because it has not violated transitive property. So therefore, we'll take this. Okay. B is A minus 2. So that is something like y equal x minus 2. It's a straight line. It's a straight line. So therefore, it is not A to A, right? Because when A is 5, B is 3. So therefore, there's nothing called A to A, because A to A will be there if it is y equal x line. Therefore, this is definitely not reflexive. Okay. And it's not symmetric as well. Okay. But definitely not reflexive. Reflexive is there if something like B equal A. So C, A is greater than or equal to B. It's something like this. Something like this. Okay. Other way. This is A is less than or equal to B. This is A is greater than or equal to B. Okay. So therefore, pretty much the same thing is applied to here. So therefore, here also it is not symmetric. AB such that B is A plus 2. It's again a straight line. So when it is a straight line where it doesn't go through the 0, 0, it is not reflexive. And it is not reflexive. So therefore, it can't be equivalence. So only possible equivalence relationship is C, because it's symmetric, it's reflexive, and it's transitive. Okay. So the answer is C. Answer is C. Okay. Right. 29. Let X 246 and Y 369 and F be a relation from X to Y. Which of the following defines a function? If it is function, there are two things that you want to make sure. That is, it must be either 1-to-1, right? It must be either 1-to-1, or it must be many-to-one. You can't have 1-to-many is not function. Many-to-one is okay, right? But it can't be 1-to-many. 1-to-many is not a function, and also there must not be any orphan values in the domain. Right, orphan values in the domain. You can't have orphan values in the domain if it is a function. Those are the two properties you have to fulfill. Right, but about this 246, 369, F2 is 9. So let's map it. 246, 369, 2 to 9, 4 to 9. Okay, that is fine, because 1-to-many is the one that can't be, and 6 to 9. That is fine, right? So it's a many-to-one relation, and all the values are mapped. Right? This is many-to-one. Many-to-one is okay. 1-to-many is the one that is not allowed. So therefore, this is a function. So what about this? 2 to 9. Let's map it again. You need a bit of patience here. Right? Right. 2 to 9, 4 to 2, and 6 to 6. 2, 4, 6, all the domain values are there, and they are mapped to 2, 6, and 9. It's 1 to 9, 1 to, but 2 is not in the range. Okay, 2 is not in the range. 6 and 9 now, okay, 2 is outside the range. Okay, which of the following define a function? If it does not, if it goes beyond your range, is it disqualifies for a function? So that is a tricky one. But within the domain, it's okay. So that means it's something like orphan value, right? Because 2 is not, 9, 2, 6, 9. Sorry, other way around. Okay, 2 to 9. Sorry, correct. 2 to 9, 4 to 2. All right. So this 2 is not there, right? Because 2 is not in the range. So that means this 4 is not mapped to a value in the range. Right? 4 is not mapped to a value in the range. It's something like, I think, orphan value now. Because 2 is not in the range. So it's debatable, but I will say no. Okay. Because your 4 is not mapped to a value in the range. Okay. But usually the definition says all your domain values must be mapped. There can't be any orphan values, and it must be 1 to 1 or min to 1. Okay. So these others are not violated, but only thing is this 2 is, sorry, this 4 is mapped to 2, which is not there. Okay, so therefore I will not take it, but it can be debatable. Okay, and what about the C? 2 to 9. Okay, I will draw it like this. Okay, 2 to 9, 2 to 3. So that is 1 to many. 1 to many. 1 to many are not functions. Right. So then again, let's draw 2 to 3. 4 to 3, that is fine, and 6 to 3, 2, 4, 6, all the values are mapped to 3, that is fine. So there are orphan values in range, that is fine. Orphan values can't be in the domain. So I will take this. Okay, and it's many to 1. What about D? 2 to 9, 4 to 6. So that means 6 is not mapped. Orphan values is there. Orphan value is there. So therefore this is not function because 6 is not mapped. Okay. So the debatable one is B, but I will take, so therefore I will not take B, but A and E I'm pretty sure. Maybe I will not take B. I don't know whether examiner will take B, but I will not take B. I will take A and E only. Okay, A and E only. 29. Yes, A and E only. The reason why we are not marking this is here clearly you can see 2 to 9 is fine, but 4 to 2, 2 is not there. So therefore we can think of 4 is not mapped. 4 is orphan because 4 is not mapped to a value in the range. It's mapping to something else. So therefore something like 4 is orphan now. Okay, that is why we didn't take. So that should be justifiable. Okay, so answer is A and E. Right, 30. Suppose f is a function defined on A. Which of the following must be false? Must be false. Okay, must be false. F is a function defined on A. So that means A is mapped to something. Right? A is mapped to something. Say A is my domain. Say it is mapped to something and it's a function. Okay. Domain of F must be subset of, sorry, domain of F must be subset of A. Right? Domain of F must be subset of A, defined on A. If it says defined on A, when we say subset of A, the equal is also there, right? And it say must be false. This is extremely tricky one. Okay. must be false. This one says domain of F must be A. That is true. Define on A. There was something called codomain also, right? Define on A. So right. So the difference between codomain and ranges, blah blah blah, sometimes mean the same, but still can be slightly different. The codomain is the set of all possible values which can come out of the results, but the range is the set of values which actually come out. Okay, so that is codomain and range. Okay, I think that has nothing to do with this question. Okay, now let's look at the answer again. Domain of F equal must, now this is anyway correct, therefore this is not answer. What we need is must be false. Domain of A must be subset of A. Yes, domain of A must be actually A. Okay, define on A, because you can't have orphan values. Domain of A must be subset of A, that is true. Then range of F must be subset of A. So we can't say something like that. Okay. Define on A. Define on A means I think range must also be in A. But anyway, you can't say must be false, right? So therefore, let's not take that. Domain of A must be subset of, proper subset of A. No. Domain of A must be equal to A, because proper subset means domain has less values than A. Okay. So if it is defined on A, domain cannot be lesser than A. It must be equal to A. So therefore, this must be false. So this must be false. I hope this is AND. They have not mentioned whether it's AND or O. Because this is false, I will say this is answer. This is answer. Okay. Domain of A must be A. Yes. Range of A must be A. Okay. Domain of A must be subset of A. A must be proper subset of range of Y. A must be proper subset of range of Y. Must be false. This is true. And this is, I'm not very sure about this, because range side we can't say much. I will go for B. Okay. Let's double check. This is a very fast question anyway. Let's say whether this answer is B, 30. They have taken C also. Okay. So YC is correct. Must be false. Anyway, B must be false, because your domain cannot be proper subset of A. Domain must be same as A. That is what is meant by there are no orphan values. Every value must be mapped. Okay, every value must be mapped. So therefore, this is definitely false. So this says domain is a subset of A. So therefore, the domain is A is there. Therefore, this part is definitely true. This must be false then. That is, range of F must be proper superset of A. That means A range must be having more values than A. That is what they say. Range must be. No, that can't happen, right? Because if it is defined on A means your domain must also be in A, range must also be in A. But this says your range is more than A. Range is more than A means some values are mapped outside the range, right? So that is why they say your range is a proper superset of A. That means definitely some values have mapped outside your A. So therefore, those items we can consider as orphan values, right? So orphan values means it can't be a function. So therefore, yes, this must be false. Okay. Yes, this must be false. Okay, so it's a tricky question, right? So your range is a your range is a proper superset of A means some of the values have mapped outside the range. So that means those values you can consider it as orphan values. Okay. Right. So the answer is B and C. B and C. Okay. Right. 31. Suppose f is one-to-one function. Which of the following is are true? One-to-one. All x, all y, when x is not equal to y, fx is equal to fy. Okay, one-to-one. One-to-one means it goes like this, right? This. When x and y are not equal to the same, x and y are not equal, fx must be fy means that those are many to one, right? What we need is one to one. So therefore this can't be. If it is one to one, when x and y are different, fx and fy must also be different. So therefore this is definitely wrong, because it's wrong means it is not defining one to one. Okay. All x, all y, when fx equal fy, if fx and fy is the same, then x and y must also be the same. Yes, right? If fx and fy are the same, that is x, say it's something like this. Let me delete this. So this is a tricky question again. When fx and fy are the same, that means this is mapped to this, x is mapped to this, y is mapped to this. If that happens, x and y must be the same. So that means it's one to one. So there's no possibility of many to one. Okay, right? If it is one to one, yes, this must be correct. Okay, this must be correct. This is not the only condition, but this must be correct. Okay, following are true. Yes, this must be true. Then this one, all x, all y, whenever fx is not equal to fy. So that is your fx is going there, fy is going there, right? Now fx is not equal to fy. It implies x and y are also not the same. If fx and fy are not same, right? Not same, that means x and y are also not same. What about if fx and fy are not same, your x and y also must not be the same. This is the square bracket. When not fx is not equal to fy, x must not equal to y. That is correct, right? So then it is one to one. Yes, right? If fx is not equal to fy, that means x is not equal to y. Yes, that is correct, right? For one to one. So then you get something like this. Right? So this is my fx, this is my fy. When fx is not equal to fy, that implies x is not equal to y. Because if that implies x equal y, then it is one to many. Right? We have to make sure that it's one to one. So what about this? Right. Exist x, exist y, not x equal y, or fx equal fy. What is that? And again, there's not also. Okay. Not x equal y or fx equal fy. Fx equal fy. That is fx and fy goes to the same value, right? Or fx equal fy higher innawa. Or x is equal to not x equal to y. Exist x exists. I can't understand what is this. It's a hell. Okay, so therefore I will say no. එක්සැමෙන්ට් වගේ බයිලා ලියන්න පුළුවන් මම හිතනවා මේක බයිලයක් කියලා. හරි මට නම් තේරෙන්නේ නැහැ. හරි බලමු මේක උත්තරයක් දුන්නොත් බලමු. මට හිතෙන්නේ මේක වෙන්න බෑ කියලා. මෙතන මොකක් හරි කතන්දරයක් ලියලා දෙනවා වෙන හුට වටයක්. Right. What about this? fx equal fy. Fx is not equal to fy. Fx is not equal to fy. That is fx and fy. not fx equal to fy when x is not equal to y. When x is not equal to y, it implies fx is not equal to fy. That is correct, right? So when x is not equal to y, fx, it implies fx is not equal to fy. So that is correct, right? That is correct. So I hope D is not an answer, right? So therefore, because it looked very weird thing, I will go for BCE. Okay. BC, B, DE. So they have not taken C. They have not taken C, rather they have taken, so E answer is okay. So this is out of question, that is correct. B answer is also okay, but they have not taken C, they have taken D. Why is that? Why is that? Why this is wrong? All x, all y, fx equal fy, when fx is not equal to fy, when fx is not equal to fy, it implies x is not equal to y. I don't know. For me, it looks like C is correct. I don't know, right? So just keep it as open question. Think about it. And if you feel like the examiner's answer is correct, just you can talk or you can put up a small note to the WhatsApp. Because it looks like for me, C is correct. And D is sort of a weird thing. Let's double check the D again. Whether D is it really correct? Exist x, exist y, not x equal y, or either x is not equal to y, or fx equal to fy. What is that? Oh, either x is not equal to y, or fx equal fy. That is something weird. Big knot. This big knot. Not. That simplification is, this is actually a logic question now. I don't see any possibility of simplifying this further. Twice not is there. Okay, just keep it for the time being. I'm not very sure about that answer. Okay, let's just keep it open. Okay, right, just keep it open. That one, 31. Okay. Right, 32. Otherwise, we are wasting a lot of time. Right, 32. Let f and g be functions defined by fx 2x minus 1 and gx 3x, where x and y, sorry, x is a real number, then f0 g is 1 is equal to which of the following? That is not a difficult question at all. Let's let me take this down. Right. F0g means F0g means f of gx, right? F0g means f of gx. Composite. F0gx means f of gx, yes, f of gx. So therefore this is first you have to do the gx, and then you have to do the fx. Okay, f0g1, so therefore g1 is 3, so therefore this is f g1 is 3 into 1 3, right? Then what we need is f3, fx is this, and we have to put 3 into 2 is 6, 6 minus 1 is 5, f0g is 5. Okay, f0g is 5. Now let's see the answer. B, right? Answer must be B. So 32 answer must be B. Let's double check the answer. Yes, answer is B. Okay, right. 33. So 33 is also not difficult question, easy question. Let f be a function defined by R, fx equal 2 times x plus 1. Which of the following is true? Right. So this is a straight line, y equal 2x plus 2. Okay, let me close this and open because it's take a little bit time to render. Let me close this and open it again. 33. I think one of you have not mute your microphone. Okay, we can hear some background noise slightly. Right, so which one we were talking about? Is this different question? 2020.
Sir.
Yes, 33, right, thank you. 33, no, right? No, this is different paper. How comes this is a different paper? This is a different paper, sorry. 2020. Sorry, I have opened a different paper. Right, 33. Right, let f be a function defined by fx equal 2 times, right, 2 times x plus 1. Which of the following is true? This is a straight line, that is 2x plus 2. Okay, so f is 1 to 1. Yes, straight lines are 1 to 1. Okay, so that is correct. Domain of f inverse, of course, f inverse. So here the domain is minus infinity to plus infinity, because this is 2x plus 2 is something like this. Right, it goes from minus infinity to plus infinity. So therefore, inverse will be mirror image like this. Okay, so that is also going from minus infinity to plus infinity. So therefore, B, domain of f inverse is real numbers are correct. Okay, because it goes from plus infinity to negative infinity. F inverse x is, let's find it, y equal 2x plus 2 means 2x equal y minus 2, x equal half y minus 2. Then I can swap x and y or whatever. So if inverse x is, it says half plus 1. No, it can't be half plus 1. It must be half x minus 2. Okay, so this is wrong. F inverse does not exist. No, F inverse exists because straight lines, F inverse exists. Right? It's a mirror image. Domain of F inverse is R, correct? And F inverse is half times x minus 1. No, not x minus 1. Half times x minus 2, right? Because y equal to 2x plus 2 means 2x is y minus 2. Yes, this is wrong. Then domain of F inverse is R, correct? F inverse is half x minus, yes, this is half y minus 1. You can write rather than this, you can say, you can write it as fx, right? Half x minus 1 over, right? You can write whatever the way you want. It doesn't matter whether you use x or y. So therefore, this is correct. Okay, this is correct. Right. So if you have x equal this, then you can write y equal. Okay. So y equal half x minus 1. So answer is A and E. Right. 33 answer is A and E. Okay, I think you are referring to logic question. Okay, so let's finish this. Right, 33, A and E. Okay, A and E. Yes, A and E. Okay, right. 34. This is counting questions. Right, counting questions. Now remember, this first you have to double check whether this is combination question or permutation question. Since you have the recordings, I am not going to do any revision. Right, so usually I do a revision at the end, but since you have the recording, because we did the counting within 1 day, right? So therefore, why don't you just refer to the recording, right? Rather than, right? What is the number of arrangements? So arrangement means permutation. Okay, can be made by taking all the letters in the word composition if the three letters O are together, right? So if we have n number of things, how many ways we can arrange factorial n? Okay, but this is all three O's must be together. 1, 2, 3. Now this is a little bit tricky question. So let's go through our note first, just to refresh. Let me know whether we have the short note for that. Should be counting. Yes, techniques of counting. Anyway, it's a very small note. You don't need a short note for that. Right. So when we have n, and if you take all n and arrange factorial n, then if you have n and if you take r and arrange npr factorial n divided by factorial n minus r, then if there are same things, and if you take all factorial n divided by factorial n1 factorial n2 factorial n3, then you have the circular arrangement. That is, this is not a circular arrangement. So therefore we must be able to do this as either this way, factorial n question, or factorial npr question, or npn, but there are similar things. Okay, right. So now let's look at the question again. Right, all letters must be in the same place. So how many C's are there? Let's write down C. Only one C. How many O's are there? 1, 2, 3. That is a special case. How many M's are there? 1. P, only 1. O is already there. S, only 1. I, 2. T, 1s. We have already taken the I. O is already taken, N only once. And but if it is, if you forget about this O concept, the answer is factorial. How many letters are there? 1, 2, 4, 6, 7, 8. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3, 4, 5, 6, 7, 8, 9 years. If this O issue is not there, the answer is factorial 11 divided by factorial 3 factorial 2. Because you have 3 same things and 2 same things, right? That is if this O together katandare nattanga. But they say if the 3 letters O are together, we have to always keep them together. Therefore, we can't spread them here and there, right? So therefore, we can consider these 3 O's as just one letter. I think that makes sense, right? Because it's something like we have bundled them, those 3 O's together, because they must be in the same position. So therefore, why don't we take this as just one letter? Right? We just take this as, rather than 3 letters, let's say we have 3 O's bundle only once. If so, what is the answer now? Now we have 1, 2, 4, 5, 6, 7, 8. This is a bundle. 9. So then factorial 9. Then this is just one letter now, but there are 2 i's. Therefore we have divided by 2. Right? So factorial 2 is anyway 2. So therefore I will go for factorial 9 divided by factorial 2. Factorial 2 is anyway 2. Therefore I will go for this answer also. This can't be the answer. This can't be the answer. Bad. So therefore answer is what? A, C. Let's look at the answer first, okay? 34. Yes, A and C. Now look at the logic, okay? So take a experience at the Ken on. Maths papers අවුරුදු 10ක්වත් කරලා යන්න. හරි. වා ඒකට A plus එකකට යන්න කැමති නම්. නැත්තම් අවුරුදු 5ක් විතර කරගත්තම ගොඩ දා ගන්න පුළුවන්. ඒ වගේ සමහරු යන්තම් සන්තන්නේ. සමහරු නිකන් මේ විභාග ගොඩ දා ගන්න යනවනේ. හරි. ඉතින් විභාග ගොඩ දා ගන්න යනකොට ටික හොඳයි ටිකක් වැලි ගොඩ දා ගන්න යන්න. හරි. මයියෝක ගොඩ දා ගන්න. එතකොට හිටවල ගියා පස්සේ ගිහලා ආයෙත් ගලවගෙන ආවා. හරි. ඌරු එහෙම කාලේ නැත්තම්. ඒකට ඔලුවක් එච්චර ඕනේ නැහැ නේද? ඒකටත් ඔලුවක් ඕන. හරි. පිංගුත්තරේ වගේ ටිකට අන්තිමට මයියෝ කාලයක්වත් බස්ස ගන්න බෑ. හැබැයි ඊට වැඩි ටිකක් හිතන්න ඕන දැන් Right. So the answer is A. Now what? Because they say 3 O's are together, I just consider it as a one letter. One letter called this. Right. ඒකට ෆොටෝ එකක් ගහනකොට යාළුවෝ තුන් දෙනෙක් ඉන්නවා. යාළුවෝ තුන් දෙනා එක තැනම ඉන්න ඕන. ඒ තුන් දෙනා නෑ බෑ අපි තුන් දෙනා එක තැනම fine. ඒකට ඒ තුන් දෙනා අල්ල ගැට ගහලා තියලා තියෙනවා. හරි. මොකද ඒ තුන් දෙනා කැමති නෑ වෙන් වෙන්නේ. ඉතින් ඒ තුන් දෙනා එක්කෙනෙක් කියතුමු. හරි. We consider that as one. So this one model of questions, right? So likewise you will find that there are different sub models. Okay, right? 35. I think that is the only, yeah, that is the only counting question. Right? Paper ekata meka counting question එකක් දීලා තියෙනවා. Right, 35. Now the probability. When the occurrences of one event has no effect on the probability of the occurrences of another event, the event are called independent. It's not dependent, not equal likely, not exhaustive, not mutually exclusive. So the answer is A, 35. That is an easy question. A. 36. 2 fair coins are tossed simultaneously. If one of them turn head, what is the probability that the other one turn tail? That is an interesting question, right? If one of them turn head, what is the probability that the other one turn tail? Do you think that the second one, whether it's tail or head, is dependent by the first one? Right? No, right? It's always the probability of other one to turn tail is 0.5, right? Whether it is head or tail or anything else. If one of them turn tail, it's already happened. Okay, let's write down sample space. Head, 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 tail, tail, head, tail, tail. Okay, so there are 4 possibilities. That is not conditional probability, just normal probability. But it says one of them turn heads. So that means already we know that this one is head. Now, what is the probability of other one being tail? It's again half, right? Because these are independent events. Okay. I will go for 0.5. Those are independent events. Okay. So 0.5, 36D and D, because it doesn't matter whether this one is head or tail, the other one is independent thing. Right, 37. 2 6-sided fair dice are rolled simultaneously. That must be easy question. The probability of getting total of 4 or less, given that both phases are similar, is that is interesting. So we have 6-sided fair dice, right? 2, okay, 2 6-sided fair dice, 2, okay. Probability of getting total of 4 or less. Now, what are the possibilities to getting 4 or less? 1 1, right? 1 1, 1 2, 1 3, 1 4 is not there because 1 plus 4 is 5. Then 2 1 1, 1 2, 1 3, 2 1, 2 2, 2 plus 2 is 4, and that's it. Then 3 1, okay, 3 1, 1 1, 1 2, 1 3, 2 1 2 2, and 3 1. Okay, so how many possibilities are there? 1 2 3 4 5 6 possibilities are there. That is getting total of 4 or less. But then they say, given that both phases are similar, they already said that both phases are similar. So it's something like, this is my A event and my B event is, both phases are similar, means 1 1, 2 2, up to 6 6. Okay, so they say both are similar. Okay, so that is if probability of A given B, right? Conditional probability when B has already happened, right? Given that both phases are similar, when B has already happens, what is the probability of A happening? Okay, so therefore it is probability of A intersection B divided by probability of B. That is the formula we did. Okay, so what is the probability of B? What are the altogether, how many possibilities are there? When we have 6 sides and another 6 sides, 6 into 6, right? 1 1 1 2 1 3 1 4 1 5 1 6 2 1 2 2 blah blah blah. We have 36 possibilities, right? So what is the probability of B happening? There are only 6. 1 1 2 2 3 3 6 6 etc. So therefore probability of B is 6 divided by 36. That is probability of B. And what is the probability of A and B happening? So out of these, there's one possibility which is here, and there's another one. So therefore probability of A and B happening is 2. 2, right? 2 out of 36. Right? 2 out of 36. So therefore the final answer is 36 to 36 get cancelled. 2 divided by 6. Okay, 2 divided by 6. Usually we do not simplify it. Okay, but anyway, if the examiner has given 1 divided by 3, I will take it, but no 2 divided by 6 anymore. No, no. So we'll go for the answer as E. Okay, 37E. Yes, 37 answer is C. Okay, so I hope you got it. So it's a conditional probability question. Probability of A happening given B has happened. So therefore, first we find what is the probability of B happening. Altogether, there are 36 possibilities when you have 2 dices. Here we have 6. So therefore, 6 divided by 36. Probability of A and B happening is 1, 1 and 2, 2. 2 out of 36. Because those are the situations both. Okay. Just we applied the rule. Okay, right. 38. If A and B are two events such that, okay, this kind of questions, it's very easy to do by using a Venn diagram. Okay, so whenever I see this kind of question, I will always go for a Venn diagram. It's the easiest way rather than using rules. A and B. So this one says 12. This one is 1 over 3. I will write this also as a 12. Okay, so because I need a universal signal. Okay, so therefore, probability of A is 1 out of 3. That means out of 12, 4, right? So altogether assume 12. So what is the probability of A happening? So that is 1 out of 3 is 6, 6. 4, 4. 4 into 3 is 12. 4 out of 12. So therefore, here we have 4. Here, inside this. Okay, inside this circle, 4. Then probability of B and not A. B happen, but not A happen. So that is this area. So it must be 5. It must be 5. So then can we find this? Can we find this? What we need is probability of not A and not B. Not A and not B. Not A and not B means outside. So yeah, not A and not B, outside. Okay. So here we have 4. Here we have 5. Not A and B is 5. Not A and B, correct. PA is 4. If this one has 4 and this one has 5, that means altogether, if this one has 4 and here you have 5, that means 5 plus 4, 9. The union is 9. Okay. පේනවද? මෙයාගේ 4ක් තියෙන්න ඕන, මෙයාගේ 5ක් තියෙනවා. එහෙනම් යුනියන් එකේ ඉන්න ඕන 9ක්. 9ක් ඉන්නවනම් මෙයාගේ 12ක් තියෙනවනම් මේ ඉන්නවන කීයද? 4ක්. මමත් හිතුවේ මේක කරගන්න බැරි question එකක්ද කියලා මම පොටක් පෑදුනා. So this is 4, this is 5, 5 plus 4 is 9. So then altogether 12. So that other 4 must be here. So what we need is probability of not A and not B. Yes, not A and not B is this. So therefore probability of not A and not B is 4 out of 12. Or if you simplify, 1 out of 3. 1 out of 3 is also from there. Right? Where are those? This is 3, right? Sorry. 5 plus 4 is 9. So 12 minus 9 is 3. 3 out of 12. Okay, sorry, 3 out of 12. Or in other words, it is 1 out of 4. Right? If you simplify, it is 1 out of 4. Usually we don't simplify, but the examiner has simplified it. Okay, 1 out of 4. Answer must be B. 38. Yeah, B. Yeah. That was a mistake. 3. 38 answer must be B. Let's double check the answer. Yes, answer is B. Okay. Right. 39. So this is definitely a මේක කියවනකොට මට තේරෙනවා මේක මොකක්ද අනිවාර්යෙන් රුක් සටහනක් නේ. Tree diagram එක. That is either conditional probability or independent events. Right. Box contains 10 marbles, of which 7 are green, 3 are white. 7 plus 3 is 10. Marble is picked at random from the box and its color is noted without replacing. Again, conditional probability. Yeah? With replacing a independent. Right. Okay, let's draw it. Say green, white. 7 are green. 7 out of 10 getting green. 3 out of 10 getting white. Right. Then without replacing the first marble, the second marble is then picked out. So then second marble is also picked out. Green, white, green, white. Only second times. What is the probability that the first marble is green and the second marble is white? Okay. So now if it is green, now we have less number of greens. So therefore 6 out of 9. Still we have 3 out of 9. Okay. I don't have to go this side also because it says if the first marble, what is the probability that the first marble is green and the second marble is white? So first marble is green and second marble is white means this area. 7 divided by 10 into 3 divided by 9. I don't have to look at this one also. So that is 21 divided by 90. First we have 10, then we have 9. Okay. Yeah, 21 divided by 90. 21 divided by 90. Shall we simplify? Out of 3, 7 divided by 30. Yeah, 7 divided by 30 is there. So therefore, let's take B as the answer. Okay. Yes, B as the answer. 39 answer is B. Yes. Okay. Right. 40. There's another counting question. Okay. What is the probability that in a random arrangement of the letter of the word university, the two I's do not come together? Bit of probability also. Right. Another interesting question. How many? What are all the arrangements? It's how many U's are there? U1, N1, I2, V1, E1, R1, S1, T1, Y1. Okay, so only two I's are there. So all together, what is the probability that in a random arrangement of letters of the word university, in the two I's do not come together? Right? Two I's do not comes together. Two I's. What are all the possibilities? 1, 2, 3, 4, 5, 6, 7, 8, 10. Factorial 10 divided by factorial 2. That is all the possibilities. Okay. Now let's look at what are the how many possibilities are there where the two I's comes together. Two I's comes together. There are 40. There are 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 10. They can be the first two. They can be this next two, next two, next two, next two. එහෙම possibilities තියෙන්නේ නේද? කීයක් තියෙනවද? ඔක්කොම 10ක් තියෙනවනේ. මේ දෙන දැන් 2යි ඊට පස්සේ ඔක්කොම තව 9ක් ඉන්න 1යි 2යි 3යි 4යි 5යි 6යි 7යි 8යි ඔහොමම ගිහිලා අන්තිමට මේ දෙන මේ කෙරවල ගිහිල්ලා ඉඳලා මේ පැත්තට 10ක් එනවා 1යි 3යි 4යි 5යි 6යි 7යි 8යි පිටි කීයක් තියෙනවද මෙතන ඉන්න පුළුවන් මෙයා මෙතන ඉන්න පුළුවන් මෙයා මෙතන ඉන්න පුළුවන් මෙයා මෙතනට එන්න පුළුවන් එතනට එනවා කීයක් තියෙනවද 1 2 3 4 5 6 7 8 9 there are 9 possibilities, right? 9 possibilities where these two can be together. 9 possibilities. This place, this place, this place, blah, 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 this place. Right? So altogether we have this much of possibilities. Out of that, two i's do not come together. So that is this minus 9. Because this is 9. So this is 9 out of this. So therefore it must be this minus 9. මෙච්චරකින් 9ක් එහෙම වෙන්න බෑ. මොකද ඒ 9 තමයි ඒගොල්ලෝ එකට ඉන්නේ. Okay? So that is factorial 10 divided by factorial 2 minus 9 divided by factorial 10 divided by factorial 2. හරිද? ලිව්වා. මොකද එච්චර 1 will be
Sir,
yes.
sir,
Yes.
it is 9 factorial.
Yeah.
Answer, sir's answer.
How can you say it's factorial 9? Because there are only 9 arrangements. But
මේව කරන්න පුළුවන්
කොහොමද?
සර් මේ all possible solutions එක අරන් ඒකේ
ඒක හරිනේ.
ඒකේ උඩ සර් all solution minus all two i's come together එක minus කරමු
all two i's together කියන එකට අපිට ආවේ 9 කියලා දැන් නේද? 9 නෙමෙයි කොහොන 18 කියලා ගන්න පුළුවන්. මේ දෙන මාරු ගන්න පුළුවන් නේ. හැබැයි ඒකට වෙන වචනයක් එන්නේ නැහැ.
10 factorial 10 factorial divided by 2 factorial minus 9 factorial එක ගන්න පුළුවන්. අර අපිට ගන්න පුළුවන්නේ 2i's එන වෙලාව
2i's එන වෙලාවල් මේවනේ මේ දෙකනේ මෙතන එන්න පුළුවන්. මේ තම පොසිෂන් දෙකේ ඉන්න පුළුවන් මේ පොසිෂන් දෙකේ ඉන්න පුළුවන් මේ පොසිෂන් දෙකේ එහෙමම එන්න පුළුවන්. එහෙම අවස්ථා තියෙන 9යිනේ නේද? 2i's එකට තියෙන අවස්ථා 9යින් තියෙන්නේ. නේ? ඒ 9 තමයි මම මේ ගත්තේ. මේකේ රෝලේ ඉන්නවා. ඒ කියන්නේ 1 2 පොසිෂන් වල ඉන්නවා 2 3 පොසිෂන් වල ඉන්නවා 3 4 ඉන්නවා 4 5 ඉන්නවා අන්තිමට 9 10 පොසිෂන් වල ඉන්නවා. ඒතකොට එහෙම පොසිෂන් 9යි එන්නේ අපිට. ඒක තමයි මම අඩු කරේ.
So ඒතර අනිත් ඒවාත් වෙනස් වෙන්න පුළුවන් අනිත් letters නෝ. factorial 9 ඉන්නේ ඒක.
ඔව් නේද? මේ දෙන්න මෙහෙම ඉන්නකොට මේගොල්ලෝ වෙනස් වෙන්න පුළුවන් මාළා කෙඩියයි. එතකොට මොකද කරන්නේ? ඒකත් ඇත්තනේ. ඒක බැලුවේ නෑනේ මම.
ඒතර factorial 9 ඉන්නවා.
එතකොට factorial 9 මේ දෙන්න එක්කෙනෙක් කියලා ගන්න වෙනවා නේ. එතකොට මේ දෙන්න ඉන්නේ අනිත් පැත්ත ඉන්නවා. ඔව් එතකොට factorial 9. Yes, so then it is factorial 9. So I forget to think about these possibilities. Yes. So then we consider these two as 1. So then it's factorial 9. Yes, factorial 9. So then this is divided. This is 1 minus factorial 9 factorial 2 divided by factorial 10. Okay, so then this is 1 minus this 9 factorial and 9 factorial will get cancelled out. Only 10 will be there. 2 into 1 divided by 10. Okay, so 9 factorial. This also we can say 10 into 9 factorial. 9 to 9 cancel. And 10 is there. About 2 is factorial 2 is anyway 2. So 1 minus 1 over 5. So that is 4 divided by 5. Is that the answer? D the answer. 40. Yes, answer is D. Right. So with your help, we managed to got it. Actually, I totally forgot the fact that when we have these two ones, we can arrange these. Actually, what you have to think is these two are bundled together. And it's something like we have 9 letter, right? Yes. So therefore, it's factorial 9. Okay. Right. So that's anyway a fairly challenging question, especially those who have not done A-level maths. Okay. So of course, those who have done A-level maths, they are used to these kind of questions. Okay. So others, think about it, and it's a very good exercise. Okay. And of course, if you feel like it's very extremely difficult, just forget about it. Okay. Because it will take a little bit of time with a lot of experience. Okay. With a lot of experience and a lot of thinking, you will be able to come up with a logic. But otherwise, these are sort of very hard question anyway. Okay. Right. So now we have done those things. Anyway, it's almost 10, right? How much I have? How much battery power I am having? Oh, 34. Okay, let's do the logic questions then. At least some of those. We have to do 14, 15. Right. And remember, I told you we are going to have another session on Thursday, but the Saturday, we are going to have a semester 1 revision. Okay, semester 1 revision. You can also, all of you can join. Right. And also maybe the March 1st, we are going to have another Tuesday, another semester 1 revision. Okay. Then in the gap, we will be having more semester 2 revisions, semester 2 past papers. Okay. Right. 14. Let P and Q be two propositions. Which of the following propositions is logically equivalent to if and only if P, then Q? Okay, if and only if P, then Q. So then, of course, we have no other option but to write the truth table. Right? We know that if and only if P. Okay, let me copy this because it takes time. Now the main issue is going to be the time. Okay, so therefore be prepared. හොඳට කාලා බීලා සීනිත් වැඩියෙන් කාලා යන්න නැත්නම් ඔළුවට ග්ලූකෝස් එක වෙන්න ඕන. හරි. එක්සෑම් එක දවසට. Right. So let's so P if and only if Q is basically P if and only if Q is true, 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 false, false, true, false, false. True, 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 false, false, true. So this is false, this is false. Then only we say if and only if. Okay. So now we have to check whether which of these are giving this same exactly same truth table. Right. So let's do it quickly. P, Q, P implies Q, Q implies P, true, 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 false, false, true, false, false. True, true, P implies Q, true. True, false means false. Remember the truth table? මෙයා හරි කියලා මෙයා වැරදුනා කියන්නේ ඔයා කතන්දරේ බොරුවක්. False නම් අපිට හැමතිස්සෙම true කියලා ගන්න. මොකද අපි challenge උන්නේ නැහැනේ. Challenge උන්නේ නැහැ ඒකමත්. Right, so then Q implies P, true, 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 false, true, true, false, 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 false can comma true. So then we have to do O, result true or true, true, false or true, true, true or false, true, true or true, true. So that means it's not answer because this is different. Okay, so A is not answer. Right, so now then answer අරගෙන පෙන්නන්න ඔයාලට එකකින් බලන්න වෙනවා. හරි. I will take the answer and show you that you get this one because otherwise it will take a lot of time. So this question is which question? You have to spend the time. Okay. This is 14, right? 14. What is 14's answer? Let's take one of the answer and I will show you that that is correct. B is answer. Right. B බලමුත් not P, sorry. Let's draw it here. Because they say P is answer. B is answer. Not, I need not P and not Q. Not P, not Q. false, false, true, true, not Q. False, true, true become false, and false become true, right? I need not P or Q. I will say X and Y. My X is not P or Q. Not P or Q. True or false? True. False or false? False. True or true? True. False or true? True. Then my Y, not P, not Q or P. Not Q or P. True or false? True. True or true? True. False or false? False. False or true? True. Now I need N. True and true, true. False and true, false. True and false, false. True and true, true. You can see exact truth table. True, false, false, true. I think you can that balance, right? True, false, false, true, right? And you have to write the exact same way. True, 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 false, false, true, false, false. Here also I use the same, right? So likewise, you will get this exact same truth table for C also. The මේවා අමාරු නෙමෙයි මේවට වෙලා යන එක තමයි වෙන්නේ. හරි මේ question lazy. හරි මේ question lazy ටිකක් වෙලා ගන්න. හරි. Right. So that is 14th. Right. 15 contradiction අහනවා නේද? Contradiction එක කියන්නේ it's logic එකක් විදිහට all false එන්න ඕනේ condition එකක් කියන්නේ. මතක නැහැ condition එකක් කිව්වේ ඒකද අපි? policy එකක් නේද? condition එකක් ඔක්කොම false එන්න ඕනේ. කොහොමද මට මතක නැහැ හරියට. හරි. ඔක් කරානේ. control 5 contradiction. Yes, contradiction means all are false. Composite no. For all the possibilities, it must be false. Make up time yana. Hari karan den nai time yana ne. Mama එකක් විතරක් අරන් පෙන්නන්නම්. උත්තරය අරගෙන පෙන්නන්නම්. උත්තරයක් අරගෙන පෙන්නන ඔක ඔක්කොම false වෙනවා කියලා. හරි. It take time. There are no shortcuts. 15 DE. මම D අරන් පෙන්නන්න. D. Right. So we have two variables PQ. PQ. So I need not P and not Q also. True, 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 false, false, true, false, false. Not P is false, false, true, true. Not Q is false, true, false, true. So then I need not P and Q. I will call this X and this not take on Y. Y. Not P and Q. Not P and Q is these two. True and false is true. False. Sorry. False and false is false. True and true is true. False and true is false. Okay. So that is my X. So then my Y. Not P and Q. Not P. Not Q one is not P and Q. This is not P and Q. Not P and Q. එකම තමයි නේ. එකම තමයි. So therefore this is not P and Q is same. False, false, true, false. And what we need is a not of that. ඒකන්ද එකෙන්දි කොහොමද? True, true, false. Not P and Q. False, false, true, false. So true, true, false, true. Right? So this is my right hand side and this is my left hand side. Left hand side, not P and Q. I'm if and only if false, true, if and only if සමානොත් true වෙන්නේ. False, true, false. False, true, false. True, false, false. False, true, false. Yes, all are false. Right? all are false එක පොඩක් truth table එක අඳින්න නැතුවත් කරන්න තියුණා මේක ඕන. මේක හරියට කොයි වගේද? x if and only if not x වගේ. පේනවා. මේ block එක ගත්තොත් එහෙම x if and only if not x. එහෙම වෙන්න බෑ නේද? හරි. කොහෙත්ම වෙන්න බෑ. නේද? මොකද මේක true නම් මේක false. මේක false නම් මේක true. හරි. එහෙම හිතන්නත් තියුණා ඒක නම්. හැබැයි අනිත් ඒවා නම් එහෙම හිතන්න බෑ. හරි මේක p implies q වගේ ඒවා එහෙම truth table එක අඳින්නම වෙනවා. හරි. right. ඒ විදිහට කරන්නේ. අපි 16ත් එක question එකක් විතරක් කරමුද ටක් ගාලා. මගේ බැටරි බැස්සොත් එහෙම ක්ලාස් එක ඉවරයි කියලා හිතා ගන්න. දැන් අන්තිම ලෙල්ල යන්නේ. itu ටික අපි ඊළඟට විස්තර කරමු. Because I just want to do at least few logic questions with you. right invalid කියලා යහන්නේ තර්ක කරමු. truth table එකෙන් දැන් හිතුවත් වෙලා යනවා. p o q not p therefore q. So what is our technique? We assume that both are true and we want to see whether this must be true. Okay, this must be true. Right. So when we say not p is true, p is false. Right. So therefore p is false. When p is false, this to be true, q must be true. Q must be true. Right. Make a false now. That make not p true now. p කියන එක න false අනිවාර්යයෙන්. p කියන එක න false වෙද්දි මෙයා look true වෙන්න නම් අනිවාර්යෙන් q must be true වෙන්න ඕන. තියා කියන්නේ q must be true කියලා. එන හරි. මේකට එච්චර ලෑන් නෑ දෙකයි තියෙන්නේ. Next one p o q not p therefore not q. Again we say these are true. Not p is true means p is false. When p is false, for this to be true, q must be true. When q must be true means not q must be false. ඒ කියන්නේ මේක හරියන්නේ. මේක must be true නෙවෙයි මේක must be false. එයා කියන එක අනිත් පැත්තයි වෙන්නේ. Right, next one. P implies q, not q, therefore p. Now these two are true. Not q is true means q is false. When q is false, okay, when q is false, this is p. P implies false is true. හරි. එතකොට මේක වෙන්න නම් අනිවාර්යයෙන් මොකද වෙන්න ඕන? මෙයා false ම වෙන්න ඕන. මොකද මෙයා true වෙලා false වෙන්න බෑ. true වෙන්න බෑනේ. එතකොට true වෙන්නේ නැහැ. මේක වෙන්න පුළුවන් එකම වෙලාව තමයි p must be false. P must be false because false implies false is true. But this guy says p must be true, but what we got is p must be false. This is not answer. Right? What about this? Not p o q, p therefore not q. Let's say true. P must be true. P must be true means this must be false. When this is false, for this to be true, q must be true. Q must be true means not q must be false. So therefore this is not answer. Last one. P implies q, p q. So this is true, this is true. P is true. Therefore this is true. When this is true, to this to be true, q must be true. Q must be true. නේද? නැත්නම් මේක true වෙලා වෙන්නේ නැහැනේ. Q must be true කියලා තමයි යත් කියන්නේ. එහෙනම් මේක හරි. Answer is A and E. 16 answer is A and E. ඉන්නරි දේවහන්නේ. ඉන්නරි දේවහන්නේ. ඒතර අපිට හම්බුනේ A and E කියන්නේ valid දේවනේ. Other than A and E. හරි. අහන්න invalid දේවා. So valid ones are A and E. Invalid ones are B, C and D. Right? B, C and D. ඊළඟ එක දැන් කරගන්න පුළුවන් වෙන්න ඕන. ඒකේ අහන්නේ valid දේවා. හරි. දැන් තර්ක කරන්න. තර්ක කරනකොට වෙලා වඩේ. Right. So we stop at this point because it's past 10.